Hi students, in this video I'll be going through the 2023 O-Level Mathematics Paper 1 question 27. So this is a question regarding vectors. Let's read the question. OMN is a triangle. P is the point on MN such that the ratio of MP is to PN equals to 3 is to 2. So they give us the position vectors of OM equals to A and ON equals to B. Okay, so let's write down some of the info in the question on the diagram. So MP is to PN is 3 to 2. So this means that MP will be 3 units and PN will be 2 units. So the total for MN will be 5 units. Okay, they want us to show in part A that OP is equals to 1/5 2A plus 3B. Okay, so OP will be from O going to P, right? So just imagine if you want to walk from O to P or you want to go from O to P, but there's no direct path that you can take. Okay, so one way that we can go from O to P based on this diagram will be to go from O to M first and then from M to P, all right? So this will be the one way that we can consider. Okay, so let's try it out and see if we can get the answer from this. Okay, so OP will be OM plus MP, right? So let's write that down. So OP will be equals to OM plus MP, right? Okay, so you can refer back to the diagram. So OP will be OM plus MP. Okay, so let's try to work based on this. Okay, OM we already know is the A. Okay, so all we need to do is to try to find out what is the MP. Okay, so if you look at the diagram, okay, based on the ratio, okay, MP is 3 units, right? So MP is 3 units. Okay, the whole thing MN would be 5 units. Okay, so this means that MP over MN will be 3 over 5. Okay, so if we were to bring the MN to the other side, okay, so MP will be 3/5 of MN. Okay, why do we want to express MP as 3/5 of MN? Because if you look over here, we know the position vectors for M and N, all right? So we can actually use that to help us to find MN. Okay, so that's basically what we want to do. Okay, so we want to change MP to 3 over 5 MN. Okay, then from here, we want to break up the vector MN. Okay, so we know that if we want to find the vector MN and we know the position vectors of M and N, then we can express MN as ON minus OM, right? Okay, so this will allow us to actually find OP already because we actually know that we are actually given the position vectors OM is A and ON is B, right? But let's try to simplify this a bit first. Okay, so if I open the bracket, so opening a bracket is just like normal algebraic expansion like this. Okay, so we will get this. Okay, over here we have OM minus 3/5 of OM, so it's just a same thing like adding and subtracting vectors. You'll end up with 2/5 OM plus 3/5 ON, right? Okay, from here you can actually factorize out the 1/5 if you want, or if you want, you can put in the A and B first. Okay, so let's say I put in the A and B first. OM is A, right? Okay, OM is A given by here. ON is B. Okay, so we can put inside here. So A plus 3/5 B. Okay, then in order to put in the form that you want, you see they have factorized out 1/5. Okay, so let's factorize out the 1/5 as well. So 1/5, then you have 2A plus 3B. Okay, so this is what they want us to show. So we just write show. Okay, so this is the answer, right? Okay, so not too difficult. Okay, so you just need to know how this vector addition works, okay, and how to express any vector in terms of its position vectors. Okay, let's move on to part B. So in part B, they say Q is a point such that MQ is 1/5 A plus 9B. So they give us the vector MQ, right? So they want us to explain why OP and Q lie on the same straight line. So in part A, we have already found OP, right? Now they are telling us to show that they are telling us that there's another point Q that's in this plane. Okay, and they want us to show that OP and Q lie on the same straight line. Okay, so before we do this question, we need to understand what does it mean for okay, when 3 points lie on the same straight line. So just an example. Okay, so if let's say we have a straight line like this, okay, then we have 3 points. Okay, let's say A here, B here, and then C here. Okay, so how do we prove that A, B, and C lie on the same straight line? So one thing that we need to do is we need to show that let's say like AB and AC, right, they are scalar multiples of each other. So in other words, we need to try to show that AC and AB okay, are scalar multiples of each other where K is a scalar. So AC equals to K times vector AB. And because they share a common point A, right? Okay, then if we are able to show that they are scalar multiples of one another, then these 3 points A, B, and C will lie on the same straight line. Okay, so over here we are asked to show that OP and Q lie on the same straight line. We already know OP. Okay, so what we can do is we can try to find OQ. And if we can show that OQ is a scalar multiple of OP, and because they have a common point O, right? Then OP and Q will lie on the same straight line. So our main objective now, since we already know OP, will be to find OQ, right? And actually we are given sufficient info just based on this equation to find OQ. Okay, so let's start with the equation given, right? So MQ equals to 1/5 A plus 9B. Okay, so from here, let's break up. Okay, since we want OQ, right, we need to bring OQ into the picture. Okay, so one way to bring OQ into the picture is to break up MQ into position vectors. So MQ can be expressed as OQ minus OM. Okay, we already know M is A, right? Okay, so this means that we should not have much problem finding OQ already. Okay, let's expand the right side. So you'll get this. Okay, OM is A, so let's write down extra step first. Minus A equals to 1/5 A plus 9/5B, right? Okay, let's bring the A to the other side. Okay, bring the A to the other, A plus 1/5 A, you actually get 6/5A plus 9/5B. Okay, so from here we can actually factorize out the 1/5, and then on top 6 and 9 have a common factor of 3, right? So we can actually factorize out 3/5. Okay, actually once you take out 3/5, you notice that over here you get 2A plus 3B. Okay, and if you recall from part A, right? Okay, from part A, okay, we actually found OP to be 1/5, or rather showed OP to be 1/5 2A plus 3B. Okay, so you can see that they are already scalar multiples of each other, because 3/5 we can express it this way, right? 3 times 1/5, 2A plus 3B. Okay, and 1/5 times 2A plus 3B is actually OP. So in other words, OQ is 3 times of OP. So we have showed that OQ is a scalar multiple of OP, and they share a common point O, and hence OP and Q will lie on the same straight line. So let's summarize this in a statement. Okay, let's write it down in the line over here. Okay, so what we can say is that OQ is a scalar multiple of OP. Okay, so if you are a scalar multiple of another, two vectors are scalar multiple of each other, this shows that they are parallel vectors. Okay, and because they are parallel vectors and they share a common point, the 3 points have to be on the same straight line. Okay, so let's write, therefore, OP and OQ are parallel vectors with a common point O. Hence, points OP and Q okay, lie on a straight line. Right, so this is actually a rather commonly seen question regarding vectors. right? Where you're asked to show that 3 points are on the same straight line, right? So you will show that the vectors are scalar multiple of one another, which indicates that they are parallel vectors. And because now they have a common point, then the 3 points must lie on the same straight line, right?